Alright, so here's where things really get interesting, and we start doing a lot of work with a lot of things that we've learned. We're going to use the rational zero test, leading coefficient of 1. So we see 1 out front here. Alright, and we're going to try to find all the rational zeros of this huge equation. Alright, so let's see. First we're going to say, alright, what are our possible zeros? So the possibles are all the factors of 6, 1 times 6, 2 times 3, divided by, there's only one factor of 1. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all the possible rational answers. All right, we need to find all of them. The next step that I think you're going to want to do on here, now there's a number of different ways. The book doesn't go this way, but I think the easiest thing to do at this point is to graph it. All right, which I've done already. I plugged in my y equals, and our graph looks like this. All right, at this point we want to know where we're crossing here. So I'm going to zoom in. I'm going to use my trusty box zoom. And let's go ahead and just zoom in on this first place it crosses, in the negative side. All right, and I'm going to trace, and it looks like we're right around -1. All right, so if I come back over here, it looked like we were crossing at -1. Not sure exactly, but I'm going to put a question mark down saying, all right, -1 is one worth looking at. Let's come back over here to our graph. I'm going to go back to our window and reset this. -10 to 10, -10 to 10. Go ahead and graph it, and then I'll zoom in on this positive 0 that we see over here to the right of the y-axis. So let me zoom in on this. Alright, I'm going to hit trace, and it looks like the x value is right about 2. So we'll flip back over here and say, okay, looks like 2 is our other potential option. And there's only two places where, if we looked at our graph, when we zoomed back out, go ahead and take it back to our original values. When we first graphed, it looks like this. It's only crossing in two places. So there's only two answers. We've got our two possibles up here. Now let's go ahead and check to see if those two places it cross are indeed rationals, or maybe we're off by a little bit and it really is -1.00153, something irrational that we're not sure about. How would we test to make sure? All right, probably the easiest and fastest way is to go ahead and use synthetic division and make sure our remainder turns out to be 0. So 1x to the 4th, -1x cubed, 1x squared, -3x, and -6. We'll start with -1. Test that one first. Alright, we got 0 as a remainder, so it does indeed work for -1. -1 is one of our zeros. Let's test 2 as well. We'll start with the same line on top. We'll bring the 1 down and go ahead and do our synthetic division here. And we do get 0 again. So it does turn out that both of these, -1 and 2, are the rational zeros of this larger polynomial. All right, go ahead and see if you can work this for yourself. All right, if you're ready, let's take a look. Factors of 6 on top, so same thing, 1, 2, 3, and 6. From the last term, the trailing term, all over 1. From the leading term, so we've got plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 as our possibles. And let's go ahead and take a look at our graph. And I've already entered it in. It's our second equation here. And we'll go ahead and graph it. Alright, it looks like it's crossing in a few places. Let's go ahead and zoom in on this area where it's crossing above and below our x-axis. Once, twice, 3 times it looks like it's crossing. So let's trace and see what we've got here. Go back to the first 0. Oh, went too far. Alright, it looks like it's right around 1. 1 possible. Let's trace back over here. Looks like it's right about 2. So that's our other option. And if we trace to our third 0, it looks like it's right about 3. All positive. So these are our 3 options. Now, can those exist? Are they on their list? Yes, they are. 1, 2, and 3 can all exist. So we got to check them all out. We'll go ahead and use our synthetic division. And so what do we got here? We got 1. We've got -6, 11, and -6. Let's go ahead and test 1 first. It works. So we'll accept +1. Let's test 2. It worked out as well. So 2 is indeed one of our rational zeros. And let's test 3 to make sure it is a correct solution as well. And we'll bring down the 1. 1 times 3 is 3. So we got -3, -9, so 2. 2 times 3 is 6. And 0 is our remainder, so that one works as well. So our rational zeros for this function are 1, 2, and 3, all positive.